So if you were looking at this and you're like, oh man, I don't know how to do, or I don't know what to do in these situations. Well, that's what this is supposed to help you with, because we've done all these different, so we've done a lot of different solving techniques, right? And there's different situations where you use different ones. This is going to help you with examples of, oh, this is this type of problem, this is the strategy I use in this situation, right? That's why we're doing this, right? All this stuff that we're going to do is stuff that you've all done and shown me you can do. It's just the challenge is, when do I do what? And that's what this will help us with. So as we go, try to take good notes, like accurate notes, because then you have everything, all the different solving techniques on one piece of paper that you can just use going forward instead of having to flip through all your notes and stuff like that, okay? These are just examples. Obviously, different examples have different challenges, right? So we'll hit as much as we can with these. But yeah, it'll be a good spot to have good notes. So as always, take really good notes. And you never know when you'll be allowed to use this. So another reason to take good notes. Okay, so for each of these, I'm going to talk about when to use it, and then we're going to go through examples of those times, those situations, right? So the first one, it's called zero product property and magic X. That's the category, right? Got to know what those are, right? What is zero product property? It's why we set y equal to 0, right? Because the zero product property tells us if we have a times b and equals 0, meaning two things that multiply to give you 0, well then a equals 0 or b equals 0. And we use that to help us. Whenever we have things that are multiplying that equals 0, we pull them apart and we say, well, one's got to equal 0 or the other's got to equal 0, and that will help me solve, right? That's why we do what we do. Now, when do we use it? Oh, wait, before we talk about that. Magic X. What is magic X? That's when we put the C on the top and the B on the bottom. And students always say, I forget which one goes where. How do you remember? Why isn't it B on the top and C on the bottom? B, bottom begins with B. B is for bottom, right? So if you ever forget, just remember B is for bottom. Put the B on the bottom. All right, so, and what are we talking about? Well, standard form, that's y equals ax squared plus bx plus c, right? So whenever we say standard form, this is what we're talking about. That's the c, that's the b, that's what we're talking about, right? Okay, so when do we use this? Two times that we're going to use these situations, zero product. All right, so for zero product property, well, we're going to use that in all cases, but we're especially going to use it if we just have intercept form. Like the first example below. Intercept form already, we go straight to zero product property. And I'll just put ZPP, right? Straight to zero product property, okay? If you don't have intercept form, you get it to intercept form. And that's if you have standard form when A equals 1 or A is a GCF, which is greatest common factor, right? So if either of those situations are true, so you have standard form, you got an A of 1, or A is a GCF, then maybe you can use magic X, right? So we do magic X, then ZPP. Okay? So let's look at some examples. And we'll label the examples as the type that we're talking about. Okay, so first one. What form is this already in? This is intercept form. So we're already ready to do ZPP, zero product property. Okay? So what does that say? It says when things are multiplying and they equal 0, we can pull them apart and say, well, either this is 0 or that is 0, right? So the things that are multiplying to get us 0 right now are this and this, right? So either that's 0 or that's 0, or both are 0. So we account for that. We say, well, I guess x minus 3 equals 0, or x minus 5 equals 0. And now we have very simple equations to solve. If x minus 3 equals 0, I can add 3 to both sides, or just think to myself, well, what must x be? And I find out, oh, x equals 3. And same thing over here. If you add 5 to both sides, or you just think, what must x be? You get x equals 5. Now, think about what we're trying to find. We're trying to find solutions, right? We're trying to find the values that make something true. Well, this would make this true. Because if I put 3 here, it would be 3 minus 3, which is 0. Negative 2 times 0 times anything is 0. 5 makes this true. 5 minus 5 is 0. 0 times anything times negative 2 is 0. So these are values that make the situation true. As we go through any of these solutions, they are values that make the equation true. Yeah?
What about the negative 2? Does that not make a difference?
Great question. The negative 2 is kind of irrelevant. Because what we're saying is negative 2 times something equals 0. Right?
Would it be negative 2 times positive 3 times positive 5?
Well, if I plug this in, this 3 right now, right? Let's just test one of our solutions. So if I plug this in, negative 2 times 3 minus 3 times 3 minus 5 equals 0, right? That's just testing our solution. Negative 2, what is 3 minus 3? 0 times negative 2 equals 0. Negative 2 times 0 is? 0 times negative 2 is? 0. What's making it 0? This part, right? The 3 that we plugged in. The negative 2 just gets washed away because there's a 0 in there. So it doesn't really matter for finding our values of x. Good question. Okay, so now, what if we have this situation? Well, this is standard form when a is what? 1, right? A is 1 here. So anytime I have an a of 1, I'm going to try my magic x, right? Because I want to get it to intercept form where we just were, because that's where it's easy to use the zero product property. So I put negative 45 on the top and negative 4 on the bottom. What's two numbers that multiply to give me negative 45 and add to give me negative 4? Negative 9 and 5. Okay? So these two numbers, exactly as they are, with their signs, go over here into our equation. And we get 0 equals x minus 9, x plus 5. Now, we've gotten it to the intercept form that we were just in the previous example. Now we do the same thing we just did. I know that these two things multiply to give me 0, so that means this equals 0 or this equals 0. And if x minus 9 equals 0, you can add 9 to both sides, or you can just say, well, that means x equals 9. That's what would make that true. And if x plus 5 equals 0, well, the only thing that would make that true is if x equals negative 5. So you could think that through, or you can actually subtract 5 from each side. You get the same answer. Okay? We're trying to always get to this place where we can pull it apart. Now, one more time where we might do this. 0 equals 2x squared minus 20x plus 48. My a is not 1, but I'm going to check something. I'm going to check if it's a what? A GCF. So that it turns out to be true. A is a GCF. Why? Everything is divisible by 2, right? So you factor out your a. Right? Which means I go, okay, 0 equals, and then I divide everything by a. Use another color. divide by 2, divide by 2, divide by 2. I don't get rid of that 2. It comes out front, and I get 0 equals 2, big parentheses, x squared minus 20x, not 20, 10x plus 24. I just divided everything by 2. Why? Because what I have now is the same as the last problem, an a of 1. And now I can use magic x. Yeah?
You said A is a GCF factor. What does that say?
Oh, it's a. So if a is the GCF, factor out a, divide by a. Okay? All right, but you're right, you could. Okay, so now I'm going to magic x. I got 24 on the top and minus 10 on the bottom. Two numbers that multiply to give me 24, add to give me negative 10. Yep, negative 6 and negative 4. Okay? So those two numbers, as they are, go into the equation. Right? And I get 0 equals 2x minus 6, x minus 4. And now I'm again in that comfortable place where I can pull it apart and say, hey, these both must equal 0. X minus 6 equals 0, and x minus 4 equals 0, which if x minus 6 equals 0, then x is 6. And if x minus 4 equals 0, then x is 4. And those are solutions. So if I took 4 and I plugged it into this original equation, 2 times 4 squared minus 20 times 4 plus 48, I would get 0, right? That's what we figured out here, what the solution to that is, right? We just changed the form to find it. That's all. All right, so those are your three scenarios where you go straight to magic x or zero product property. Yeah. All right, but sometimes we have an A that's not 1 and it's not a GCF. And we need another strategies or two strategies for that. So that's where we're going next, okay? So reverse box or rainbow method. So you can use either of these. We're going to do them both just to show you both your options, right? And you get to choose going forward which one you want to do. So when do we use this? Well, standard form again. But A does not equal 1 and is not a GCF. Neither situation, right? It's not 1, it's not a GCF. So if you look at this example, 2x squared minus 7x minus 15. You can't divide 7 and 15 by 2 and get a nice number. It's not a GCF. We need something else here. So the two things we talked about were reverse box and rainbow method. Okay? So we'll do each, okay? So first for reverse box. Okay? So you want to make a box. And you don't have to, but I like to put the extra square over there, and you'll see why. And then the first thing you do is you put ax squared, this part, right here. And you say, okay, 2x squared. Okay? And then you take c, this part, and you put it right here. And you get, and of course that would be, negative 15. Okay? Now, what goes in the other two parts? Well, eventually we want this right here to end up there. So these two have to add up to that part, right? So that's what we're going to end up doing is finding two pieces that would give us the negative 7x. Question?
We plug in negative 7x to the little box?
Into the extra box, yeah. Because we want them to add up to that. Okay, how do we find the numbers that add up to that? At this point, we do a times c. So a times c equals something, right? In this case, that would be 2 times negative 15, which is negative 30. And then we say, okay, I need two numbers that multiply to give me negative 30, and then they add to give me negative 7. Two numbers that multiply to give me negative 30, add to give me negative 7. Anybody know? Negative 10 and 3. Multiply to give me negative 30. Negative 10 and 3. Add to give me negative 7. And I throw them in the box. I say, okay, negative 10x and positive 3x. And I double check. Does that give me my negative 7x? It does, right? Okay, now we factor out. I factor out. So what does that mean? Well, 2x squared and minus 10x. What goes into both of those? 2 goes into both 2 and negative 10. And then x squared and x, so I can pull an x out. Okay? Just pull out the pieces you can. And then I ask myself, well, 2x times what gives me 2x squared? X. And I start filling in these pieces. 2x times what gives me negative 10x? Minus 5. X times what gives me 3x? Plus 3. So now look what I have. I have the two factors, right? These things right here are the factors that I was looking for, because that's what we're trying to do is factor, right? So now I solve. So I have 2x plus 3 times x minus 5 equals 0. And again, I'm in that zero product property place where I can solve this, right? So I say, okay, that means 2x plus 3 equals 0. Minus 3, 2x equals negative 3, divide by 2, x equals negative 3 halves is one solution, right? And then, make some space here. And then for this one, x minus 5 equals 0, well then the x equals 5. And that's my other solution. Okay? So if I had 2x plus 3 equals 0, I just solve that two-step equation. Minus 3 on both sides, divide by 2. Negative 3 over 2, yep. So that's one way you could do this. The other way is called the rainbow method, which is a little different. So, but it's going to give you the same answers. Okay?
So
all right.
you're just going to ask us to find both solutions?
Yes, I'm just asking for solutions. This is just giving you all your options. All right. Now the other method. Well, the other method is called the rainbow method. So hold on, I'll write this equation again. It was 2x squared minus 7x minus 15 equals 0. Now, it's called the rainbow method because it really helps you focus on this a times c. Because you got to do that again. And we already did the math, so I'll just write it down. Negative 30, we know negative 30 equals negative 10 plus 3, right? Or, sorry, times 3. And then negative 7 equals negative 10 plus 3. Remember, we already did this math up above, right? Now, what do I do with this? Well, I take this number, this negative 7x, and I pull it apart into those two numbers. And I rewrite the equation as 2x squared minus 10x plus 3x minus 15 equals 0. So I'm just turning negative 7x into negative 10x and plus 3x, right? That's negative 7x, right? I'm just pulling that apart, right? Now what I do is I look at the two groups. This is the first group, this is the second group. And I GCF each group, right? So 2x squared and minus 10x, what goes into both of those? We kind of already did this above, right? 2x. And that gives me x minus 5 when I divide both of these by 2x. What goes into 3x and minus 15? 3. So that gives me x minus 5 when I divide both of these. Okay? Now, which part?
Did you split up the x squared for the first one?
So 2x squared and minus 10x, you can divide them both by 2, and you can divide them both by x. So you pull out both the 2 and the x.
Okay, thank you.
All right, so what does this give me? It gives me this x minus 5 twice, right? That becomes your new GCF that you can pull out. You just pull that out front. And this is x minus 5 times 2x plus 3 equals 0. And that should look familiar because that's what we got up above, right? If that's confusing, like pulling out a GCF that's a full binomial, just think the thing I got twice goes out front, the other two pieces go right here, right? This and this end up over here, okay? And you'll get the right answer. Okay, now I solve it just like I did above. We already did this, so let's just say x equals 5 and x equals negative 2/3. I'm sorry, 3/2. And there you go. Okay? So, two methods for solving these when you don't have a GCF and your A is not 1. Holy moly. All right, on to the back. All right, so isolating the square. Isolating the square. Okay, so when are we going to, first of all, isolating the square means get the square by itself and then square root, right? So the two times you would do that are 1, standard form, but missing the bx term, missing that middle term. Okay? The other time you would do this, vertex form. Now these examples that I'm including aren't the hardest, right? Sometimes you have to add, subtract, then divide. This one we'll just have to add for the sake of an example. So I'll point out what I mean in a second. So I'm isolating the square. This is the square, right? To isolate it, it means get it by itself. So I'm going to move the negative 24. So I add 24 to both sides. And I get 24 equals x squared. Now, sometimes there's a number in front of the x squared. You would then divide by that number before you square root it. This doesn't have that. Okay, so what do I want to do now? I want to square root to get x by itself. I get x equals square root of plus or minus square root of 24. Now, the square root of 24 I want to take over to the side and say, square root of 24. Can I break that apart into, and when I think break it apart, I want to find a perfect square inside of it. So I start dividing by perfect squares. I look at those red boxes and I go, 4, yeah. It would be the square root of 4 times the square root of what? 6, right? And then that's helpful because the square root of 4 is
2.
Plus or minus 2. So this becomes plus or minus 2 square root of 6. Now this goes in place of the square root of plus or minus square root of 24, right? That's why we did it. So it turns out our answer is actually x equals plus or minus 2 square root of 6. Now, you can write this down if you want. I'm not going to. How many solutions do I have? 2. One of them is plus 2 square root of 6. The other is minus 2 square root of 6. Those are 2 solutions. Okay? All right, next one. Ready? Okay. Here we go again. We want to isolate the square. This is vertex form. The other one above it was the missing bx, by the way. This is vertex form. So if this is the square, how do I isolate it? Add 8. Plus 8. Plus 8. I get x plus 4 squared equals 8. Now, sometimes there's a number in front of this that you would then divide them both by. We're lucky this time there is not one. Okay, now I would need to square root and square root. I get x plus 4 equals plus or minus the square root of 8. Okay, again, I can take 8 over to the side, square root of 8. That becomes square root of 4 times square root of 2, which is plus or minus 2 square root of 2. And that goes in place of the square root of 8. So I get x plus 4 equals plus or minus 2 square root of 2. Now, have I gotten x by itself yet? No, so I minus 4 on both sides. And my answer is x equals negative 4 plus or minus 2 square root of 2. Okay? One more. I know we're short on time, but don't worry. You don't have homework. All right, last one. Now, this is, when do we use this one?
None of the others work.
When nothing else works. Or
All the time.
whenever we want. As long as it's standard form. Standard form only. But you could always convert to standard form and still use it. All right, so real quick, here we go. Here is our situation, here is our formula. So I find my A, B, and C. My A here is 1. My B is negative 10. My C is negative 14. Okay? Plug each of those in. X equals negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 14. All over 2 times negative 1. Oh, not negative 1, 1. All right, evaluate the pieces one at a time. Meaning negative 10 is 10. Plus or minus, I'm going to come back to that, over 2 times 1, which is 2. Now, I put this into my calculator. Put this in your calculator. And I get 156. I want to break down the 156. I'm about to do this real quick. I apologize. This breaks down into plus or minus 4 times square root of 39, which is plus or minus 2 square root of 39. You would have got there yourself. One last step here. I have 10 plus or minus 2 square root of 39 over 2. The last thing I do is I look at this number, and this number. I don't look at the radical number. You can't reduce the radical number. And I ask myself, can I divide them all by something? What? 2. So I do that. And this becomes 5 plus or minus 1 square root of 39 over 1, which is really just 5 plus or minus the square root of 39. And there you go.